Good morning, good afternoon, good evening, ladies and gentlemen, and in today's video, we're going to be taking a look at equivalent rational functions. Now, when we take a look at equivalent rational functions, what does it mean for it to be first and foremost equivalent? Well, for example, let's say we have 2 over 3. Well, how can I write something that's equivalent to this? And when we say equivalent, we mean like similar, and it could be made using one simple multiplication. So, for example, let's try to multiply the top and the bottom here. Remember, sibling law, you gotta multiply the same number. Let's try multiplying them by 2. That would give me 4 over 6. This fraction here, or rational, was made using my original, but just multiplying it by a singular number. Okay? So let's say I give you another one. Say 4 over x. Well, I can also multiply this by 2, which would give me 8 over 2x. All right? Now, obviously, you have to always remember that when we're talking about rationals, your bottom can never equal 0, so you have to have restrictions every time you talk about them. So my restrictions, in this case, is x cannot equal 0. Because if x was 0, then I'd have 2 times 0 on the bottom, which is 0, and then I'd have 8 divided by 0, which can't happen. All right? Now, you can also do the same thing, multiply by many different things. I can multiply by, let's say, the top and the bottom by x, which would give me 4x over x squared. In this case, you know, the restriction is still going to be x cannot be 0. I can also multiply the top and the bottom by, let's do something fun, x minus 1. Which would give me 4x minus 4 divided by x squared minus x. In this case here, my restrictions are going to be a little different. Obviously, x can still not be 0. And if I factored the bottom, then I know x can also not be 1. That's also because if I put 1 here, I'd have 1 minus 1, which is 0, and then the whole bottom becomes 0. If I put 0, then the whole bottom still becomes 0. So in this case, I have 2 restrictions, 0 and 1. Right? Now, the problem here, in this case, is they have the same restriction, but I have a second restriction. And because I have a second restriction, this would not be equivalent. Because remember, for them to be equivalent, they have to share the exact same restrictions. So, in conclusion, equivalent functions. And obviously these aren't functions right now. We're working with expressions because, well, they're not equal to y or f of x. So equivalent functions, there are 2 rational expressions or functions that, number 1, top, bottom, multiplied by same value. And number 2, they share same restrictions. All right, so you have to keep this in mind. They have to share the same restrictions. So let's use this definition and see whether we can find out if things are equivalent. All right, so let's take a look at these. So I'm asking you, are the equivalent? So I have 9 over 3x minus 1 and negative 18 over 2 minus 6x. Now, clearly, if I take a look between these two things, I know that negative 18 is made when I multiply 9 by negative 2. So let's try this out. I'm going to multiply this by negative 2, and if I do that to the top, I got to do that to the bottom. And that's going to give me negative 18 over negative 6x plus 2. And now when I take a look at them, I notice my 6x is negative, my 2 is positive, and I've got negative 18 on top. So we've met the criteria. Okay, so we've met our top, we've met our bottom, and the second part is we need to now figure out if the restrictions are the same. Now the restrictions for my first one, well, 3x minus 1 is on the bottom. So what would make that equal to 0? Well, bring the negative 1 to the other side. Divide both sides by 3. So x cannot be 1 over 3. What about the second one? Well, the second one, 2 minus 6x, make that equal to 0. So I'm going to bring the negative 6x to this side, so I'm making it positive. Divide both sides by 6, which is also 1 over 3. So they both have the restriction of x cannot be 1 over 3. They both have the same top and the bottom made by only multiplying one thing. So I can say, therefore, they are equivalent. All right, so let's try the same thing with this one. Now, I'm going to take a look at these two, and I've got x minus 1, I've got 2 minus 2x. Now I can turn x minus 1 into 2 minus 2x by multiplying by negative 2. And whatever I do to the bottom, I've got to do to the top, at the bottom as well. All right, so let's do that. That's going to give me negative 2x plus 2 divided by negative 4x. Now, here is the problem. I've got a negative here. I do not have a negative here. So, just by looking at that, my first criteria is not met. So this is not equivalent. I don't even have to look at the restrictions. All right. So let's take a look at another example. All right, so let's take a look at this question. Once again, the best thing to do when they are like this, where I can't see what I would have to do, is factor it out. So I'm going to factor this out. I can divide them both by 3, which will leave me with x plus 1. I can divide these both by 2x, leaving me with x plus 1. Great, and that actually tells me what I need to do. I need to multiply this by x plus 1. And same thing on the bottom. Which is going to give me 3 times x plus 1 and 2x times x plus 1. So they're now similar in their equation. The next thing you have to do is you need to figure out your restrictions. And my original restrictions here would be, so I know that x can't equal 0, and it also can't equal -1 due to this. In this case, x just can't equal 0. All right? So because x can't equal 0 in this one, but it can't also equal -1, this one has another restriction that this one does not have. So therefore, they are not equivalent. And that's it. That is how you look at equivalent rational functions. Hope you have all enjoyed this video, and thank you, and have a great day.